My name is Franz Pinard, and I'm the ESB International Business Development Manager for Africa and Asia. And we do work for ESB Networks, the Irish distribution operator, on the electrification project, preparing the design specifications and processes to allow for an increase in decarbonisation and distributed energy generation, and an increase in electricity use due to electric vehicles and heat pumps. ESB International is a world-leading energy engineering consultancy firm, and over the past 45 years, we have operated in over 120 countries worldwide. They offer a comprehensive range of solutions right through the life cycle of their projects and the energy value chain in sectors including transmission and distribution, thermal and renewable generation, emerging energy technologies, energy trading and regulations. Key to our success has been our deep-rooted utility background and our fully integrated structure, which gives us a comprehensive and unique understanding of all aspects of the energy sector. Today, my panel and I will be discussing distribution, utilities, and the changing landscape, specifically around renewable energy. We have a panel of experts who will explore the reasons a transformation is taking place, some of the challenges we are facing in utilities, and we will review a roadmap towards the new energy landscape. I would like to introduce Claire Duffy, who is a Network Development and Electrification Manager with ESB Networks in Ireland. Claire is an expert in decarbonisation, sustainability and energy usage, and developing solutions that will help deliver on Ireland's emissions target. Why are we moving towards renewable electricity and decarbonisation?
We're looking at what areas can we reduce emissions, and that leads us into energy and heat and transport are major factors that are currently have quite high emissions, and there's an ability or an opportunity for us to be able to do something around that. So for us, it's about trying to say, how do we decarbonise electricity as a starting point, right? So adding more renewable energy, low carbon energy sources, and then moving heat and transport to electricity, so moving away from fossil fuels. And then you're then using that cleaner, lower carbon electricity. So actually solving the heat and transport with cleaner electricity. So that's the main driver. As part of that, there is a move that towards what we call active energy citizens, okay, or in some countries looking at the term prosumers. So for us, we define an active energy citizen, well, firstly, an energy citizen as someone who understands that their behaviour has an impact on the electricity system, and an active energy citizen is one that deliberately and systematically changes and alters its behaviour in order to have that impact, a desired impact on the electricity system. So when the government is looking at how Ireland is going to achieve its overall climate action plan, a big portion of that, or a contribution from that, will be from active energy citizens looking at decentralised energy solutions, looking at microgeneration, and looking at seeing how we use electricity and our energy in a different way. That's not to say we won't have the larger generation plants, but they will be the larger wind farms, larger grid connected solar. So we're seeing that there's no one silver bullet. So we're going to have to look at a range of solutions in order to be able to deliver Ireland's overall emissions target.
What are the initiatives around decarbonisation, digitalisation, decentralisation, deregulation, and democratisation mean for ESB Networks?
Well, from a very practical perspective for me and for my teams on a day-to-day basis, what this means now in terms of these new initiatives around digitalisation, decarbonisation, decentralisation, etc., is that we are actually having to repurpose our electricity network to cater for what's coming now in the future. Okay, so the way that people will look to use the electricity system, so not just from their own electricity demand in homes, but also now increased demand around their electrification, their transport needs, so electrifying their transport needs, electrifying their heating needs, and then trying to say, okay, how do we repurpose the network to allow for example, two-way power flows? It wasn't designed for that. It was very much designed, as you talked about earlier, large centralized generation coming down through the transport system, which is essentially the transmission and distribution system, down into customers, be that commercial industry and the domestics, right? So now we're saying, okay, we need to allow for two-way traffic, particularly at the low voltage network. We also need to have better eyes and ears down into the lower voltages so that we can give customers better information about what's going on in their area, that we have better sight know what's going on, so that if there's new initiatives going on that network and people are using our network in a different way, that we have enough information to be able to keep everything stable and secure. And so very much that's what it is. And for us, a lot of the innovation that we're seeing now is really coming down into that interface between active energy citizens, or prosumers, whatever you want to call it, that interface with the electricity distribution system. And that's where we're seeing a lot of innovations, be that through the communications they're using, Internet of Things, the smart devices in their homes, where they're maybe working with new market players, different aggregators and others like that. So you can have some who'll say they want to take part in this new type of market and these new types of services, but they want someone else to do that for them, so they cannot sign up via their electricity suppliers or these aggregators. And then others who'll want to be more active in themselves.
Next, we have Christopher Mayende, who's a Deputy Director of the Kenya Power and Lighting Company, the distribution utility of Kenya, who will give us a perspective from the Kenyan power sector point of view. What does the future look like for the large-scale adoption of renewable energy?
Over the last few years, there have been a tremendous reduction in the levelized cost of energy, and most of our customers already started defecting to solar. Currently, not so bad, but most of them are actually either in the process of developing some captive generation, or already have developed and are already enjoying relatively cheaper energy from the sun during the day. And when we, as KPLC, looked at all the numbers, we realized that there is a shift in the market from conventional generation, and decided that we need to offer a wholesome solution, which includes energy that comes from conventional generation in the country, as well as facilitate development of captive solar generation for our customers. So we began just a year ago working on a model for captive solar generation, where we will, the company will not invest, but we will facilitate private developers who are suitably qualified by the company to develop captive generation for selected consumers who choose to join the program, and provide energy to KPLC, which is then sold to consumers through an equipment leasing arrangement. At the moment, we've just closed a tender for the selection of the developers who are expected to partner with the company. And upon completion of this particular exercise, the company will be issuing out RFPs to those who are qualified for certain pre-selected sites. We are seeking approval, of course, from the government for an approval of the first 200 megawatts to be developed under this scheme. And thereafter, we seek to obtain a certain percentage of all new generation to be developed through this arrangement. In this arrangement, the generator on paper will effectively be KPLC, because the KPLC will obtain the generating license from the authorities, and the private developers will bring in their equipment and generate under KPLC's license. So that way they will be insulated from the delays that come from acquiring this kind of licenses. KPLC will also undertake project development. That includes the feasibility studies, pre-feasibility studies, grid interconnection studies where applicable, environmental and social impact assessment studies, and any other and meeting any other regulatory requirements required, so that all the developers have to do is basically to source for the financing, deploy the solution, and then operate the plant for durations of between 10 to 20 years.
How will you ensure that there is a continued investment in renewable energy, and how will costs be managed?
This is something that we are currently considering, because the Energy Act 2019, which is the new law, has made a provision for net metering. While at the moment we are still working on, the government is still working on the regulations to operationalize this provision in the Energy Act. we believe that for us to be fully operationalized, the grid will also have to be ready for this kind of energy uptake. It is happening already. There are certain small consumers who have installed solar PV on their rooftops with their grid inverters, and they have already connected, although the percentage is small, and so we are really not feeling the impact like we'll feel in the event that a lot more consumers choose to go that way. So at the moment, we have two worries. The first worry is that the interconnection, the connection of the microgrids brings a challenge with regard to operation of the grid, because ideally, from the system control perspective, I should be in control of all generation on the system, which I am not, especially for the case of the small generators who are connected through energy meters that I do not have control of. So we're really looking at this. Number two, we are looking at the possibility that there is generation from places that we do not expect to have generation. So there are safety aspects, especially when we are switching off the system for the purpose of maintenance. Number three, we are also looking at the fact that we already have commitments with the large power generators. And so this is generation that is coming in a way that is not scheduled. And so we need to look at it in terms of, yes, we can get cheaper or even free energy at the moment in the absence of the regulations and even a tariff. But on the other side, we have to look at the effects. So the grid, the offtake at the moment, therefore, we are saying this is something that we may not stop, but then we need to be ready for it. And we just haven't done much, especially in terms of making ourselves ready for mass uptake.
What challenges do you foresee from an interoperability point of view, system controls, energy balance, and overall system management?
Yeah, one of the challenges that KPLC is facing is that of system stability, security of supply, being able to sustain a stable system through control and operation. And this is because most of the customers, we do not have communication up to the level, up to that low level of 240 or 415 volts. We have a few customers who are on smart metering, and the ones on smart metering, we can at least disconnect them through the meter, and because there is a communication link either through a GSM or through our own fiber optic network, which connects probably much of our large power customers, who are just probably about 8,000 out of the 8.5 million customers that we have at the moment. Now, the question of promoting rooftop generation, especially by small customers, is a tricky one, because we don't have control of this generation. For us to have the control of this generation, we kind of have to improve, make the grid smart, so that we know who is generating what at what particular time, and then we have control of it. The other issue is much of the generation is from intermittent sources. And so at any given time when we are operating the grid, there are significant variations in the output from these rooftops plants, especially if they are of solar or wind. And previously, we have been maintaining the stability of the grid using geothermal and hydro, which are now reducing in terms of their overall contribution to the grid, because there is significant expansion of wind and solar as we move forward. It takes long to deliver geothermal plants. Although we have theoretical capacity of about 10 gigawatts, we've only managed to deliver something less than 1 gigawatt over the period from 1984. So the speed at which solar is growing is not properly matched by the growth in geothermal and hydropower. which have been helping us to stabilize the operation of the system. And so in the event that there is significant growth of this generation, what we are seeing ourselves doing is that we will be running much of the diesel generation, the HFO-fired diesel generation, which again comes at a significant cost, because to manage those variations in the generation, then we have to bring in a more stable baseline baseload generation. So bringing the diesel is now more expensive, and it pushes the tariffs higher. And currently, we are among the most expensive within the sub-Saharan region. And so this is reducing the competitiveness of our manufacturers. And so it is also something that is undesirable. But as we said, because the regulation now provides, the law now provides for customers to supply themselves up to a maximum of 1 megawatt without ever seeking any authorization, it is difficult many times to know who is now generating and who is not generating. But we are trying to normalize this through the development of the regulation, which should be out within a period of 1 year.
I want to thank the panel for a great discussion and finish up with a few comments. Distributed renewable power generation goes hand in hand with decentralization of power generation and the control of the power balance. This means an increase in system reliability and system resilience because customers and generation units will be closer together, and there will not be need for extensive transmission systems prone to failure when there are large-scale catastrophes like large-scale fires, monsoons, and storms. We'll also see a reduction in losses due to shorter energy flows, traveling less distances because generation is closer to consumption. We'll see in the future large power plants be replaced by small-scale renewable generation owned by small businesses and homeowners, which in aggregate will generate as much as large power plants. All of this will come at a cost. It will require an increase in investment to cater for bidirectional power flows. And because of different electricity usages, a different type of network, and more control down the distribution level. Grids in Africa, like all over the world, are smart, but rarely at distribution level. We need more data, we need more control at low voltage level, and therefore that will require investment and a change in how we operate our networks. Africa can leapfrog the rest of the world, and has already proven to do that with the connectivity and mobile telecoms innovation. And therefore is ready to make this paradigm shift to a decarbonized economy in decentralized generation and an increase of electricity usage. So USB International has the expertise to deliver this energy journey to any utility or any partner or any company in the world. Please get in touch with us if you want to learn more and work with us. Thank you very much.